Okay, question 4, we've got a question that's going to look at contact pressure and it's going to look at fluid pressure. So a donkey has a weight of 2,500 newtons, happy with that. The area of each hoof, and there is 1, 2, 3, 4 hooves. So I'm going to have to multiply that by 4. It says calculate the average pressure it exerts, and we don't have to do anything with that. So PFA, want the pressure, so let's just follow that. So the crucial part is I need 4 lots of the area equals 0.088, and then I can put it into the force divided by the area. Have a quick check. We know that pascals is newtons per meter squared, so I do not need to change that, and I do not need to change the newtons either. So 4 hooves, P equals F over A, put it all together, 28,409, and it says in the mark scheme you could round that any way you wanted. Okay, next one, figure 7 shows the shape of a camel's foot is different, so let's get this again, PFA. The camel and the donkey have the same mass, so that means this is the same. Explain how a camel's hoof is more suitable, so we can see it's got more area. So we've increased the area. This is the same, so pressure will go down. So the camel will not sink into the sand as much as a donkey. So the camel's hoof has a larger surface area. So there's less pressure because we've got the same weight and the force is spread over a larger area. Just be careful that the force is spread. Don't ever say that the pressure is spread over a larger area. Because if we're looking at this, it's the force divided by the area. It is not pressure equals pressure over area. So just be really careful with your wording. And we're going to use this idea of this one stayed the same, the other one's gone up, so that one goes down, or increases and decreases. Student carries out an investigation to show how pressure varies with depth. They've got a pressure sensor here, and it's connected to their mobile phone. They're then going to change the depth, and then we can see this here. So I've already put the line of best fit in because I really struggle with astigmatism in terms of graphs. So plot the 2 missing points. So we can see we're missing that one and we're missing that one. Whoops. And then you just have to put those in like so. Draw a line of best fit so it's a straight line. Make sure it intercepts. Now in physics, anytime you get an intercept, you're probably going to be asked about it. And what we can see is, well, this part is the fluid pressure. And this must be the atmospheric pressure before we put it in. So we know it's 98.7 at the surface due to atmospheric pressure. I'll put AP. And then as I move it further down, we increase the total pressure because we're now adding the water pressure. So which of this represents a straight line? Hopefully from maths, you know that's y equals mx plus c. So this is the intercept, this is the gradient. It says use the graph to predict the pressure at the surface of the water. So as I said, that'll be this intercept here, which is 98.7. The student repeats the investigation using seawater, and it tells us seawater is more dense. So compare the graph. So we know P equals H rho G, and if this part's going up, why have I put a down arrow? If the density goes up, the pressure will go up. So if it was doing that before, it's going to go up and it's going to be a steeper line. It's going to intercept at the same point because we haven't changed the atmospheric pressure. So the pressure would be greater, so there's a steeper line. And both would intercept at the same place, and because the atmospheric pressure is the same. Now, that mark was missed by lots of people. And that one, people said the pressure would be greater, but they didn't mention that it'd be a steeper line because it says compare the graph. So you've got to talk about the graph, not just what's going on. And that's that done.